Hello everyone, this is Mustafa from the Code Show, and today we have another Leetcode problem. This is one of the classics of dynamic programming. What we have here is we have the problem itself is about you have like amount of coin or amount of money, and you need to find how many ways you can make up this amount of money, and you have array of coins you can use to make up this amount. Okay, we have an example. If we have like if we have £5 or $5, and we have like coins of 1 and 2 and 5, there is how many ways we can make up this 5 out of this coins array. So actually here we have like 4 ways to make up this this amount. We can choose only directly 5, and we can use 2 and 2 and 1 and 2 and 3 ones, and we can use also 5 ones. How we can implement this solution, or how we can solve this one? It's actually to make it much more easier, let's solve it into two phases. Okay, so the first phase, let's write a backtracking solution that will solve the problem, but it will handle it like in much smaller constraint. So after we develop the backtracking solution, we will enhance it and we will add the memoization part. It will actually help us to have more coins, and we can use more coins or more amount to solve the problem. So without further ado, let's start with building our backtracking solution. So first thing, let's take the length of the coins into another variable, length. Okay, and we need to write a recursive function that this recursive function we will need to call it, and it also will call itself again. So this is part of our backtracking solution or recursive solution. Okay, and our function will take the reminder and the current position of where we are currently at the coins. Okay, so if we are here, this is the position, this is the first position, second position, third position, and so on. Okay, and we need to start, or we need to solve from the amount itself. So we need to solve from the amount and the index of 0. Okay, so this is the first part. So let's write our base cases. Okay, actually we have 2 base cases. Okay, so the first one, if we already take the whole amount and we don't have any amount left, so we already take this 5 and we have like 0, so we don't need to we don't need to do any another codes. We just need to return 1 as we already took this pass, and this pass is already good for us, and we already reached our goal by making up this amount of money. So we need to return 1 to indicate this pass is good. Okay, and we can use it. Also, we have another base case. If we if our position reached the end. Okay, so we reached the end of the coins because we weren't able to make up this amount of money out of these coins. Okay, And let's write our uh, two recursive calls. Okay, so the first one, we need to check, okay, if the reminder is larger or equal, sorry, larger or, or equal the current position of coins. Okay, so actually if we have the reminder is larger than this current position of coins, that's actually means we can subtract from the reminder this amount. Okay, we can subtract from the reminder this amount. Okay, so we can call solve again, and we need to call the new reminder. Put the new reminder will be like coins, will be the reminder minus the coins of the current position. Okay, and the new position surprisingly will be the same, and we need also to solve from the next position. Okay, so we will leave it like this: solve reminder and position equal +1. Yeah, I think I have type here, position. Yeah, so what actually this mean? This means we need to solve from the current coin again, because if you see here, we can take the coin, the same coin in this amount of time. So here we take one like 5 times, and we to return it. So we need to solve from the same coin again. So we here we pass the same position again, and we also need to solve from try another solution by adding the reminder, and we need to try with this reminder another coin. Okay, so here we trying another coin, and here we trying the same coin. Here we took this coin, so we subtract it from the reminder, and we didn't take it, so we didn't subtract it from the reminder, and we need to return. So and else if we didn't find this reminder is larger than the current position of the coin, so we need to try from the next position. Okay, so we need to solve from reminder minus sorry, not this, yeah, reminder position +1. So we are trying another solution or another coin. Okay, so this should be our backtracking solution. Okay, this solution without memoization, so we can consider it as a dynamic programming solution. Let's just try it, and let's see if this solution will work for this case. It should work, otherwise we have an issue in our code. Yeah, it works fine. Now the next step is that we need to write the dynamic programming part or the memoization part. Okay, so to do so, actually we need to create a table, or create an array that we need to use it to cache the solution from a specific coin. So how to do that? We need to define a new array. Let's call it memo, and this memo is actually a new array. Okay, and the length of this array is n+1, and let's fill it up with another arrays to make it like 2D arrays, because we need to cache two things: the reminder and the position. I'm saying reminder all the time. It's the remaining and the position. So this is the remaining and this is the position. So Yeah, this should be something like that. var equal var I equal 0, and we need to tell them I is less than memo length, and need to increment the I, and we need to say that memo of I equal new array of amount plus 1. Okay, and we need to fill memo I fill it with minus ones. Okay, why we add it like this? Because we have like sometimes we can have solution like 0 and we have solution like 1, so we will never have a solution like -1, so that will indicate that we didn't have or we didn't use this position before, and we can calculate it from here. Yeah, so let's build let's include this in the recursive part or the backtracking part. So we need also to add here another if statement, another base case. So if memo of the current position and the current remaining is not equal -1, so we need to return this. Okay, so we already calculated before, we need to return it. So this is the first part, and we also need to cache the solution here, and we need to cache it here. Okay, so this is the solution. At the end we need to return it. Okay, so that should be it. We didn't return, so it will never return, so we forgot this one. Let's submit it again. Yeah, it works fine and perfectly submit it. Yeah, thank you for your time. Hopefully this help you to understand a little bit the solution of dynamic programming and the basics of dynamic programming, and as I mentioned in the beginning of the video, this is considered as the classics of dynamic programming problems. So hopefully you understand it well. If you have any question, please let me know.